Hi everyone, and welcome to my Research Ed Norwich talk on disciplinary literacy, or why I think we should be teaching maths words well in the mathematics classroom. Just to give you a little bit of background information about me, my name's Lisa Coe. I can be found on Twitter at LC2110. I currently work for Mathematics Mastery as a development lead, and prior to that I was a primary school teacher and maths lead. So we're going to start by thinking about what exactly is disciplinary literacy. Now, I came across this phrase when I was reading an essay or a blog, I can't remember quite which, by Alex Quigley, and there was a throwaway comment. So he said that disciplinary literacy is based upon the idea that literacy and text are specialised, even unique, across the disciplines. And that was it. That was the only comment about disciplinary literacy. So I actually tweeted him and asked him about it, and then fell down this rabbit hole of research that I'd like to share with you today. So Skinner et al. Describe it as an investigation of a word or a symbol or a phrase, but that has meaning specific to a particular discipline. So in this case, we're going to be talking about maths. And I really think that we should be interested in this because various people, including our CEO, our founder of Mathematics Mastery, Helen Drury, talks about the fact that mathematics is abstract. It can be explained and learned, but only through the language and the symbols that we use. And so therefore, if pupils can communicate using this kind of mathematics register, then actually they feel more like a mathematician themselves. And so we need to create a culture, create a school classroom environment where actually children can be encouraged to use that language and have opportunities to learn that language really, really well. So let's take a closer look at some of the mathematical vocabulary and the potential challenges that we have within that. Dave Hewitt's research and work on mathematical language is something that I recommend everybody should read, and you can find the full link to the paper at the end of this presentation. So he talks about the fact that names can feel arbitrary for students because there isn't a particular reason why something has to be called that particular name. So a square is a square because it is. Now this applies to everything, not just maths, so tables are tables because they are. And so he talks about the fact that all names are things that students need to be informed about, and it's very much part of our role as teachers to make sure that we inform students of such things. And so we need to think really carefully about how we are introducing mathematical vocabulary in our classrooms. So there are lots of different ways of defining and categorizing vocabulary. You may well be familiar with the tier 1, 2 and 3 structures, but I particularly like this way of describing mathematical vocabulary, which has come from Monroe and Puncherson, and they define the different categories of mathematical vocabulary in a way that I really like, and I think that it really helps us understand the challenges of mathematical vocabulary. So I'll just go through these here, and we're going to spend a bit of time looking particularly at one of these different types. So the first type is technical, which is one meaning specific to mathematics. So for example, integer can only mean a whole number. There isn't another possible meaning. It has one meaning, and that is very mathematically specific. Then we have the sub-technical vocabulary, and we're actually going to spend a little bit of time in a moment unpicking this vocabulary. So sub-technical vocabulary has more than one meaning, which varies between different content areas. So actually pupils might not understand or know the mathematical meaning. So volume is an example of this, and as I said, we'll look at further examples in a moment. Then they talk about general vocabulary. So in mathematics, we use worded problems, and we also explain using our general everyday vocabulary. But actually, if pupils haven't encountered that particular word or those particular phrases before, then they can't even access the maths because they don't understand that vocabulary. And then finally, we have the symbolic vocabulary. So the symbolic vocabulary is those symbols for mathematics that we use. And again, they're very abstract. And if pupils don't understand what that digit 3 means, if they don't have a really good understanding of it, then they're really stuck. The researcher Duval wrote a really interesting paper relating to this idea and talked about the fact that actually all mathematics is abstract, and so the only way that we can understand that digit 3 and get a really good meaning of it is through understanding representation. So we understand the digit 3 means 3, and we know what that means because we have a kind of Rolodex, if you like, of lots and lots of different representations of it. So let's take a look at the sub-technical category in a little bit more detail. Sub-technical words are really complicated because, as again Helen Drury points out, the many words in mathematics have a general and a specific meaning, but they also have different meanings depending on which area, which content domain you are talking about. One of the challenges of vocabulary in mathematics is that some words have more than one mathematical meaning. So, for example, the word degree, we measure temperature in degrees centigrade in the UK, but we often refer to that as just degrees. So it's around 26, 27 degrees today. And then also we have degrees that are the angle of rotation. So we talk about a right angle being 90 degrees. Now, obviously, the word degree here both mean units of measure. But this can be confusing to pupils because are they the same thing? Is 1 degree centigrade the same size as 1 degree of rotation? And of course they're not, but actually these two things can become interlinked and can be confused by pupils. Another example is square. So we obviously have a square being a four-sided regular polygon, and we talk about 5 squared, or finding the square of 5. Now, as adults and as experts, we know that these are actually linked, that that square numbers create squares. But actually these can become confusing for pupils, particularly where square numbers are taught procedurally or are not taught thinking about that connection. At this point, I would invite you normally to think about some words that are sub-technical, so that have more than one meaning in everyday language and mathematical language. The word factor is here, and if you want to pause me now, you're more than welcome to have a think about what different experiences of the word factors might pupils come to your classroom with. So I'm going to share a few examples with you. The first thing that comes to mind is the X factor. So the X factor meaning, I don't know, something intangible, something particularly talented or special, which obviously isn't the mathematical meaning. We also have factor 30 sun cream. Now, factor 30 in terms of sun cream is actually mathematically related. It's 30 times, it's a factor 30 relationship, but actually I'm not sure how many people understand that and really explain that well. And factor here is almost like an adjective. It just describes the sun cream. We talk about needing to factor things in, or it's a factor in my decision. And actually, when we think about factor in mathematics, what we're actually talking about is numbers that multiply together to make another number. So 4 and 5 are factors of 20. But actually, children will have come to the mathematics classroom with all these different ideas of factor, all these having heard of lots of different things. So we need to be really careful in thinking about the prior experience when we try and teach the mathematical version of the word factor. So there's also further confusion where some mathematical words are related, but students confuse their distinct meaning. So we've already spoken about factor, and factor and multiple are one of the big things that I found as a Year 6 teacher children confused. They didn't know which was which. They did when I prompted them, but actually they used to confuse them. Sometimes things like hundreds and hundredths, which have to be pronounced really carefully, can be confusing, and pupils often confuse numerator and denominator in terms of the top and bottom numbers of the fractions. So there's all this confusion about mathematical language, and there is a wealth of mathematical vocabulary that pupils should or need to be introduced to. Hopefully, seeing this evidence, you agree with me that we need to be really careful about how we teach mathematical vocabulary. So we're now going to look at some strategies for teaching maths vocabulary. Pearson-Fontaine's research into strategies for teaching mathematics vocabulary looks to the work of Isabel Beck, who wrote Bringing Words to Life, and suggests that actually we should follow a similar approach in mathematics. So we need to offer definitions, we need to give lots of opportunities for pupils to encounter the words, and we need to enrich the verbal environment of the mathematics classroom. So in essence, we need to be using lots of mathematical vocabulary, lots and lots and lots in the classroom, and giving pupils lots of opportunities to use those words. Pearce and Fontaine talk about the importance of sharing really good definitions with pupils, and one of the ways in which I've found that works really well for this is using the Collins Co-Build Dictionary. Feel free to pause me now and go and have a look for yourselves, but in essence this provides very, very simplistic definitions for words, not just maths words, but it's really good for most maths words. It provides them in the simplest possible way with lots of links to any more complicated words that might be used so that you can go and explore as well. And it's a really good tool to have to start to think about how you're going to define these particular mathematics words. The other thing that some people find really useful is thinking about morphology and etymology of words. So, for example, we have digit, which is from Latin digitus, meaning finger. Now, our digits are 0 to 9, and so we can count those on our fingers. And so for some children, that may help them remember. When we think about circumference, circumference is meaning around or surrounding, and so that's really, really useful to remember that the circumference, which bit of the circle is the circumference. Angle is from Old Latin angulus, meaning corner. So, you know, having angle and corner quite connected in your head could be really, really useful. And then we have decimal, so the dec is from deca, 10, which obviously supports decimal, decagon, decade, and our base 10 system for numbers. But are they actually useful? One of the things that we need to think carefully about is when we use morphology and etymology and when we don't. So one of the things that is a sort of interesting point really is thinking about numerator and denominator. Now, as people with understanding of what a numerator and a denominator is, I think these definitions are quite useful. So numerator comes from Latin's numerare, to count, a denominator, denominare, to name. And so if you think about 1/4, we have the numerator of 1 and the denominator of 4. Now it's a quarter, so we are naming it with the denominator. So actually that can be really useful. However, if you put yourself in the position of a child and think about how we say fractions, 1/4, 2/4, then it's quite easy to identify that they might think the naming part of the word is the first part, so the 1, 2 and so on. And therefore they might think, well, if it's to name, then the denominator must be the first number, the top number, the number 1. So if we say 1/4, because actually if you think about their attachment to names, if you say my name, Lisa Coe, you know that my first name is Lisa. And when they're counting as well, children's early experiences with fractions often involve counting the equal parts of an image. So if you have quarters, you'll have 4 equal parts, and they're going to count those 4 equal parts to check that there's 4 of them. So it's quite easy to see that they could get those confused. A useful definition, though, I think, is isosceles. So isosceles comes from iso, which means equal, and skelos, meaning leg. So isosceles literally means equal legs. Now, the reason I find this interesting is because I think children have a really strong attachment with isosceles and triangle. And so, therefore, if we can introduce this etymology with them and get them to really attach the idea of isosceles to this concept of equal legs, then when they encounter an isosceles trapezium, for example, they are much more likely to identify it that way rather than just attaching that word isosceles to a triangle. So let's put that into practice. We're going to use the word acute, which is an adjective. We're going to think of the definition. So this is the Co-Build definition of an angle less than 90 degrees. Now it's worth pointing out at this point that actually that definition does require some prior knowledge. They need to know what an angle is, they need to know what 90 degrees looks like, but in the classroom, in the primary classroom, this will be built upon. So I'm assuming that children know the concept of an angle and the concept of 90 degrees. If we look at the etymology, it comes from the Latin of acute, which means needle. Now, this can be a useful thing, I think, because we can think about an acute angle being the smaller angle of the different definitions. But actually, we need to be really careful because an angle of 89 degrees, which looks nothing like a needle point, is still an acute angle. So it might be useful, it might not be useful. I think I would choose to share it dependent on the children that I had in front of me. One of the things we need to think really carefully about when introducing new mathematical words to pupils is the examples that we use. And again, I'm going to turn to Dave Hewitt here, who talks about the fact that where the word has to be associated with the right things. Now, he's talking about shape, but actually this applies to any kind of concept that we're talking about in the maths classroom. Not only do pupils have to know the word, but they have to really strongly associate that with examples. Returning to our acutes then, we can think about the critical features of the word acute. So rotation shown about a point is less than 90 degrees. I wouldn't necessarily share this with pupils, but it's really useful for a teacher to think about so that when we think about examples that we're sharing with the pupils, we can really carefully think about what examples that we're showing that focus on those critical features. When thinking about acute, we need to make sure that the examples that we're showing show those critical features, but in a range of ways. As you can see from my examples here, I have different arms, so the purple and the orange examples at different lengths, and I've shown the angles within shapes, and I've also shown the acute angle without the rotation marker. And I'd give children lots of opportunity to point to one and say, this is an acute angle because it is less than 90 degrees. Within examples, it's also really important to show non-examples. So I've just got a couple here. These aren't exhaustive, but they give you an idea of the possible examples and non-examples that I would use. Again, I'd give pupils lots of opportunities to say these are not acute because they are greater than 90 degrees. It's really important that we think about the examples that we're using to show the full range of possibilities for, in this case, acute. Returning to our in practice slide then, we have now a range of things to think about the word acute. As I've said, I wouldn't necessarily share all of this with pupils, but I think this is a really good blueprint for sharing any word. Make sure pupils have lots of opportunities to say the word, to feel how it feels in their mouth, so to speak. Think about the definition and then ensure that the examples that you are using really show those critical features, as well as examples that do not show those critical features, and therefore examples that are not acute. That's really important as well. So for any word, this is a really good way of planning how you're going to introduce that word to ensure, or to start to ensure, that depth of understanding. In terms of the application then, Claire Lee talks about the fact that actually in a maths classroom, quite often we as teachers use lots and lots of mathematical vocabulary, but pupils themselves don't have a chance to do that. And therefore she talks about the idea of the mathematics community and pupils who don't understand that language, who aren't given opportunities to use that language, don't feel part of the maths community. It's really important, as I keep saying, that we give children lots of opportunities to use these maths words regularly in full sentences and allow them into that community, allow them to talk about their maths. Because at the start, as I said, Helen Drury identifies that if pupils can talk about maths confidently, then they feel more like mathematicians. And if pupils feel more like mathematicians, then they are more likely to engage with maths and to have a real go and learn mathematics. So in conclusion, I'd like to share one of my favourite quotes, which is, "You mediate the subject of maths through the language of maths," which is from Alex Quigley in Craig Barton's podcast with him. So we can't understand maths unless we understand the language of mathematics. It's really important that we make sure that the maths vocab is taught making the same connections as other vocabulary. We tend as primary school teachers to teach historical words or science words or words in our English grammar lessons really, really well. But how much attention do you really spend thinking about maths language? And can you use some of the strategies I've shared today to support that? We need to pay attention to the different types of vocabulary, perhaps using the Monroe and Panchinson links that I've shared today, or tier 1, 2, 3, to identify those particular words that may cause problems and think carefully about how we're going to remedy that. We need to use morphology and etymology as a hook if it's useful to do so, and we need to make sure that the representations that we carefully attach to that vocabulary are really meaningful, considering those critical features. To summarise then, just to sum up, here are some of the glossaries and word lists and things that I find useful when thinking about mathematics vocabulary, so you might want to explore those. And then towards the end we have some references as well, so you might want to pause and jot some of these down, particularly Dave Hewitt, as I've said. So just to summarise, thank you very much for coming along to my talk. I hope that you have a better understanding of maths vocabulary and the challenges, and hopefully you've got some ideas to take away and use in your classroom.